Hello, this is Jeremy, and I'd like to welcome you to the first Math 143 online video. So typically you'll have a few of these for each of the sections, and they'll cover the examples that you find in the notes. So in this first video for section 2.1, what we're going to do is look at a couple of the methods to solve systems of two equations with two unknowns. Now from now on, I'm just going to say we're going to be dealing only with linear equations. So that means that the variables only have an exponent of 1 on them. And so there's a lot of applications that involve these that we'll see throughout the course. And that's the big focus of this course, is on applied problems. So we'll definitely be talking about that, but also the methods you need to solve the systems or whatever else we're dealing with later on. So hopefully you're somewhat familiar with this. As a little bit of a review. What we want to do is we want to find the value for both variables that satisfy all the equations, which in this case would be 2. And we have a few methods available to us. And so that would be elimination, substitution, and graphing, which you should be comfortable with all of them. Finally, we also could solve with matrices, which is something we'll talk about next week. So looking at substitution first. Substitution has its place. Often when you have one of the variables that has a coefficient of 1, that's the number multiplying the variable, it's going to be easy to use substitution. In other cases, it's probably overkill to use substitution. Technically, you can use it to solve any system of equations, but again, there's some cases where it's easier and some where it isn't. So if you look at this example, the x in the first equation has a coefficient of 1. Now, there's no coefficient, so it's understood to be 1. And so with the substitution method, what we do is we pick a variable to solve for first. Well, if this has a coefficient of 1, then what we'll do is we'll pick that one to solve for. So this would be equivalent to x equals 7 minus 2y. And so now what I do is I take this, I say, well, if x equals this, can't I put this in place of x in the other equation? And certainly you can. And then what you'll have is an equation that only involves y, and you'll be able to know what y is. If I was to do this, I would end up with the equation 2 times, now I'm going to replace the x, 7 minus 2y, minus 6y equals 5. And so distributing the 2, I get 14 minus 4y minus 6y equals 5. Combining like terms, 14 minus 10y equals 5. So minus 10y is equal to, and so I'm subtracting 14 from both sides. So if I have negative 14 and 5, then I have negative 9. And so y equals 9 out of 10. 9/10. Now, when you come across an answer like this, what you should do is leave it as a fraction, a simplified fraction. And if it's a fraction where the top is bigger, the numerator is larger, you'll leave it like that as well. And so now once you have the value of one of the variables, it's easy to get the value of the other. You can plug into the original equation. It says x plus 2y equals 7. So now I know y is 9 over 10. So x plus 2 times 9 over 10 equals 7. And before you take out a calculator, you can if you want. There's no need, right? So 2 and 10, they share a like factor of 2. So this would be a 1, this would be a 5. So this is really x plus 9/5 equals 7. In other words, x equals 7 minus 9 over 5. And instead of getting the calculator, I'm going to keep going. But like I said, it's okay if you don't. You can just use a calculator here. Just make sure you put it into fractions. Let's see. So if we have a denominator of 5, then if I want a denominator of 5 over here, I would have 35 over 5 minus 9 over 5. And so 35 minus 9 is, of course, 26. So I get 26 over 5 for x. So there's a couple ways to write this. You could simply say x equals 26 over 5 and y equals 9 over 10 and be done. Or the other method is to put x first, 26 over 5, and then comma 9 over 10. In other words, write it as an ordered pair, and both are correct and both are all right. So as you can see, the substitution method is quite straightforward, right? As long as you have that coefficient of 1. If we didn't, then this initial term that we solved for would not have looked as pretty. It would have been a fraction, and then we're introducing complication when we don't need it. So we need another method. And this other method maybe is a little more generalizable. Not that you can't do substitution on complex systems, but elimination is much easier to do with more complex systems. So with elimination, what I want to do is I want to pick a variable to eliminate. Usually when I look at a variable to eliminate, I try to find what could cause me the least work. What could I do that would be the easiest? And then what I'll do is I'll multiply one or both of the equations by a number so that when I add them up, that variable's gone. And so when I'm looking at this system in particular, a 3 and a 6, I know it's easy to turn a 3 into a 6. In other words, I can multiply by 2. Turning a 4 into a 3 is not as easy with multiplication. Maybe I could multiply this by 3, this by 4. It's a little easier, though, if I was to multiply this first equation by something. So, for example, if I was to multiply this by -2, then I would now have a system of equations that's equivalent because I multiply both sides, and it would be minus 6x minus 8y equals positive 44. Got to be real careful about the sign there, and then my other equation stayed the same. And as you can see, the first two terms are essentially opposites. When I add them up, they're going to be gone. In other words, I eliminated the x. I could have also eliminated the y. It's really up to you which variable to eliminate. Sometimes one is easier than the other. So when I go through and add these now, this is gone. I end up with minus 5y equals 35. And so, of course, y would equal -7. Now remember, before, once we had the value for one of these, we could plug it in to get the other one. So it doesn't matter which equation I'll use, I'll just use the other one. We have 6x plus 3 times y, but we know y is -7 equals -9. So 6x minus 21 equals -9. And now we have 6x equals -9 plus 21, which would be 12. And so therefore x equals 2. So much nicer than maybe the last one as far as the answer goes. So we get 2 comma -7. If I was to write it as an ordered pair, this would be my solution. Now you should be comfortable that sometimes the answers are going to come out rather nice like this, and sometimes they're going to come out as fractions that are kind of messy, you know, like a 47 over 11 or something like that. It depends on the application we're doing, whether that's important or not. Later on, we'll have to consider, like if we're working with real life stuff, can y really be negative? Can we really have y equal something less than 1, like a 1/4? And that's something we'll consider. But right now, you should be comfortable with these two methods of solving any system of two equations with two unknowns.